Okay. So we'll look at it. So here's the control points you chose. And presumably in the same order as here. Looks about right. And then you estimate the fundamental matrix. Which I have no idea what it should look like other than there's a 1 kind of in the lower right corner.
Yeah, I didn't really know what to look for there. So, yeah.
What I usually look at is this.
Yeah.
The fact that if you run through there, you should be getting a bunch of things very close to 0, some of which are inliers and some of which are outliers. And usually, the inliers are much smaller than the outliers from those numbers. And then we extract the camera intrinsic matrix, and from there we calculate the essential matrix. And to test that we got it right, we would use the control points themselves as a test, but that's all right. So problem 2 is we are going to use the extrinsics to calculate the essential matrix. And then from that, we're going to calculate the fundamental matrix. And then we're going to see how that compares to the one in the previous problem. So let's see how that went. Okay, so you selected some points, hopefully, that lie on the checkerboard, and you found their associated world points. From that, you got the essential, you got the extrinsics, and you did that for both images. And we had some formulas for calculating the the essential matrix from the extrinsic matrix. And I mean, this looks familiar, even though I'm not looking at every single detail. So there's an essential matrix. You used one control point to verify that it satisfied it. We could have done all of them, but one of them is reassuring. Okay, so we could compare this essential matrix with the one on the previous problem. Did you do that?
I compared the fundamental matrix.
Okay, let's go down. So you calculated the fundamental matrix.
And so the fundamental matrix in problem 1, the values were a lot smaller than, well, except for the 1 in the corner. So I don't know why that was, but.
I don't either, but I think I've seen that before.
Yeah.
I know why. It's not the same essential matrix.
Because of how it's calculated?
Because we did it from the extrinsics. Before, we did it from the camera calibration data.
Right.
So it's a little bit different route. You'd have to do a detailed study of how the inliers and outliers and the matches went. But. Okay, so the third problem. We're going to probably pick one of the cameras. No, we need both of them.
Yeah,
So then we're gonna back project. Are we on 3? Find the projections. So the things with numbers that are very close to 0 for the Z, those I would expect to be points on the checkerboard.
Yep.
And so the other numbers ought to be things like 0, 12, you know, they ought to be divisible by 3. So you can get some idea of the uncertainty by just looking at the combinations. I assume you have done that.
Yeah.
And then the other thing you can look at is, I don't know, maybe you did something graphically. There's the points. So 4, 5, 25, 24, those are on the checkerboard.
Oh, if you, which problem is this? This is 3.
I'm looking at the numbers here. 8 is on the checkerboard, or at least the height of the checkerboard.
Oh yeah, so the height is down, if you go further down. Oh wait. Oh yeah, height of box.
Okay, so now you're focusing on like looking at 14, 15, 17,
Yeah.
18.
And if you go all the way to the top, you can see the actual dimensions versus what was calculated here.
Okay, so you got 6.6 compared to 7.25, and 3.4 compared to 3.75. And this is not an unusual difference
Yeah.
in measurements. So that's what I'm looking for, right? Here, that's 3. Okay, now we're looking at the epipolar line. Okay, so there's the data point you're focusing on, and I assume you used the null of the fundamental matrix to do the epipolar line.
Yeah, so there's another point I picked as well for the second. Scroll down a little bit for the second line, and then I did the null, and then also the intersection. So 2 different methods of calculating the. Scroll down a little bit.
There's nothing down.
Sorry, go up. Just go up, right above the image. So epipole from intersection.
Oh, here we go.
And then epipole from the null.
So the X null gives you the epipole, the intersection of these lines gives you also the epipole, and then you can look at the agreement there. Okay. So this is not too different than what we did already. So that looks all right. All the feature detection methods. So we've got the Harris feature, brisk features, fast, minimum eigenvalue, on and on and on.
Yeah, the only thing with this one, the last feature that I tried to do, it wasn't found in the toolbox. I don't know if they got rid of it.
What, the KAZE?
Yeah, it said it couldn't find that function.
Yeah, I don't know whether, they probably got rid of it, I don't really know.
Or it was added, or I might have an old version of MATLAB and it was recently added.
All right,
That might be what happened there.
let's test that.
Okay, I have 2016.
Did I spell it right?
If you go to, I think the page was feature detection. I think that was the title of it.
We'll try that.
Oh, there it is. On the left, feature detection and extraction. And then if you scroll to feature matching, that's what it was. Oh, never mind. Go back one. Maybe that. Yeah, detect features.
Yeah, there's no,
So it must have been
so I'm not sure where it was, but it
yeah,
doesn't
I
seem
saw it
to.
somewhere. It must have been.
It's in 2017.
Is it in? Okay.
Yeah.
So I must have been looking online.
So hopefully you told us which one seemed to work the best.
I don't think I did. That one didn't really work too well. Harris. There was one that had like 200 points and you couldn't really even see anything. $333.
333. All right, so there's no telling what's going to happen when you try that. But, the interesting part is just trying it and seeing how it works out your combination. Okay, so number 8 should, I mean, you probably found stereo 3 to be
Yeah, it was
helpful.
really useful.